All right, today we're going to talk about the quadratic formula. Quadratic formula is this here. X equals negative b. Some people like to say the opposite of b. Plus or minus the square root of b squared minus 4ac, and that whole thing is over 2a. When we say x, we mean the roots of the quadratic equals that. There's a little song to remember that. It goes like this. Clear out my pipes. X equals negative b plus or minus square root b squared minus 4ac all over 2a. That's enough singing for me. All right. You can use this when your equation is in standard form. Standard form equation is y equals ax squared plus bx plus c. A, b, and c. A is your coefficient to x squared, b is your coefficient to x, and c is your constant. This only works if your y is set equal to 0. And I'll show you what that means in just a moment. Also, in this equation is the discriminant. The discriminant is underneath the square root sign right here. The discriminant can tell you three things about a quadratic equation. If the discriminant, once you evaluate it, is positive, there are two real roots. If the discriminant, once you evaluate it, is negative, there are no real roots. And if you evaluate it and the discriminant is 0, there is one real root. All right, let's get down to a problem. The problem I want to work on is number 4. 2a squared minus a minus 13 equals 2. Problem I have here is it's not set equal to 0. What I'm going to do is, if you can see, I've subtracted 2 from both sides. That made this equal to 0. And negative 13 minus 2 is a negative 15. And I subtracted negative 2 from 2 here. That's why I have this 0. So this is my new equation. My a is now 2. My b is negative 1. And my c is negative 15. And I have that reflected right here. And so I'm going to start putting that in the equation. Remember, it is x equals a negative b, or the opposite of b. So the opposite of this is a positive 1. Plus or minus the square root of b squared. Well, negative 1 squared is 1. Minus 4 times a is 2, times c, that's negative 15. Extend that. And that whole thing, the entire thing, is over 2 times a. Good. Now we can move on. Let's do some multiplication in our heads quickly. So we have 1 minus, well, let's just leave that alone for right now. What we have is 2 times a negative 15, that's a negative 30. Negative 30 times a negative 4 is a positive 120. And so that's actually plus 120. And over 2 times 2, well, 2 times 2 is 4. Now we can rewrite this again. 1 plus, the square root of 1 plus 120 is 121. This helps us out a lot because 121 is a perfect square. So the square root of 121 is 11, so I can rewrite this again as 1 plus or minus 11 over 4. Sorry about that, 4. All right, now I have two instances in which I can find my answer. All right, the first one being x equals 1 plus 11 over 4. And the second one being 1 minus 11 over 4. The first one will give me 12 over 4, which we know easily is 3. So that's our first root. And remember, this is going to have two real roots, and I'll tell you why in just a moment. This one will have 1 minus 11, which is a negative 10 over 4, which reduces to a negative 5/2. And that's our second real root. And so I can say x equals negative 5/2 and 3. Let's talk about the discriminant in just a second. I mean, right now. Remember, the discriminant tells us how many roots there are. And so if it's positive, there are two real roots. If it's negative, there are no real roots. And if it's 0, there's one real root. Let's look at our discriminant. When I evaluated this, I found that the discriminant was 1 plus 20, which gave me a discriminant of 121. That's a positive number. Therefore, I should have two real roots. Let's look at our answer. 1, 2 real roots. The discriminant is correct. So that's how you would do a discriminant problem. And I want you to do all the problems on that page, and just be ready to be quizzed soon. All right, have a good day.